Okay, welcome back. Let's again take a look at the trust authority components with a little more detail here, and then we'll get started thinking about what the configuration of this would entail and what are all the other services that we might be needing to be made aware of. So first things first, again, we have over on the left, we have the trust authority cluster. I always like to refer to this as the blue cluster, right? This is the cluster, is that small management cluster, doesn't need to run any virtual machines. In fact, these are locked down ESXi servers. Not very big, but locked down. In fact, the only account you'd ever log in to that cluster would be this user who has been assigned the trust authority administrator role, and that vCenter is really performing just that one function of managing this cluster. And this cluster has a trusted key provider associated with it. So in older versions of vSphere, right, the previous version, for instance, that key manager would be associated with this vCenter, right? Because you think about our more traditional compute environment would have a vCenter server, it would have multiple compute clusters, and you'd have a KMS server if you wanted to encrypt your VMs over here. But there's nothing over here that would prevent us from running encrypted VMs if a host somehow had failed some kind of proof that it had booted securely or that it had been remotely attested properly or not, right? If it had failed that remote attestation, all that happens in a more traditional vSphere environment is that there's an error message, but nothing that prevents a VM from running over there that needed to have a requirement on a trusted environment. Here, on the other hand, we've got a trusted key provider associated with this cluster. This cluster has listed authorized ESX servers that need to be the trusted ESXi servers, with also a limited set of ESXi software versions that could be running on those trusted ESXi hosts. If anything fails the tests, these hosts fail their attestation, which means they are not trusted. If they're not trusted, any operation that required trusted servers can't run on any server. So imagine you have, in this case, a 3-node cluster, and normally all 3 hosts should boot up into a trusted position, right? They should be trusted, and therefore every VM in those clusters should be able to move and migrate to any host that's in the cluster. But if a host somehow fails that, right, so you end up having just 2 hosts, well, the VMs that are meant to run in trusted hosts can only run on 2 of those 3 hosts, since the third host, which may have booted and may actually appear to be functional, but it didn't pass the trust authority's verification, then you can't have any trusted applications on that host. So that's pretty neat. Extra layer protection, right? So the reasons for doing this, right? You require attestation for key access, right? In order for the hosts to hand down the keys to these hosts in order to perform encryption, these hosts have to be trusted. If they fail that trust process, then they will not be sent down any keys, right? The trust authority uses a hardware root of trust. That's defining these servers. These servers must have been configured in secure boot. They must have been configured with those TPM chips so that they can be booted securely, be able to be remotely attested, right? The key handoff is going to be handled through these hosts. It is not part of the handoff through vCenter like it would have been in the previous versions of vCenter. That means I can encrypt this vCenter server when using the VTA, right? Not this vCenter. This vCenter is really meant to just manage this small little cluster, but this vCenter, which would be managing your hundreds of VMs or thousands of VMs and all the other hundreds of ESX servers, well, that vCenter could not be encrypted in 6.7 if you were using VM encryption, but you can encrypt it now in vSphere 7. So thinking of the steps involved in getting all of this configured, you need to have this trust authority admin having that role assigned not just to the trust authority cluster vCenter, but also the traditional compute cluster vCenter, right? Your standard vCenter that's managing all the compute clusters that you have in your environment. This trust authority admin needs at that level of privilege on both systems. Because what will happen is this trust authority admin, first thing he's going to do is going to get the identity of all these hosts, the green hosts, and export those identities from that vSphere environment, doing all that from the vCenter server. Now over on the blue side, the trust authority cluster, we'll go ahead and enable the trusted host services in this cluster. Now, enabling that basically starts up a couple extra services that normally aren't running on the ESX server. We'll take a look what those services are in an upcoming slide. Now that we've got the trusted host services running on our blue cluster, we can now take the host identities that we exported out of those servers, and we're going to import them into this trust authority cluster. So now this cluster knows who he's supposed to be remotely attesting, right? And then in there we can configure all the other rules about what software versions, what TPM hardware vendors that we were able to support on that cluster. Another thing that we'll do in the blue cluster is enable the trusted key provider, right? This is something that you'll need to define for the cluster, not for the vCenter server. Then another part of this, it's a two-way trust. The trust authority admin needs to then take these hosts and their identities and export them so that we can then import them into the trusted cluster. So this cluster will only be able to be remotely attested by servers that it trusts. So it's not going to be able to be remotely attested by any old server out there. It can only be remotely attested by a known good set of hosts by exporting the identities from using the Trust Authority admin and then importing into the cluster on the attested cluster, the green side. And then we finally configure the Trust Authority cluster as the key provider for the attesting cluster so that whenever any kind of VM needs to be encrypted over here, the keys that we'll use will be handed off through the Trust Authority cluster. Because it is actually possible to still use regular standard VM encryption using this vCenter, but that would be using just standard encryption without requiring the trusted computing. And so if you've got this as an attested cluster, then it will get its keys from the trusted key provider as opposed to from a standard key provider. So once again, to kind of thinking of all the different components, we've got our hosts that are to be attested. Again, the green ones, right? They must have the TPM chip. They cannot be part of this root of trust without having that TPM chip. These hosts, by being part of this remote attestation, now they're not being attested by vCenter, they're being attested by this cluster. These hosts that are in the attested host cluster are going to run an extra service called KMXA. That stands for the Trusted Infrastructure Agent. However, the agent needs to be able to talk to somebody, right? Well, that means our trust authority hosts, the hosts that are in the actual VTA cluster, the cluster that's actually remotely attesting all these compute clusters out there, they're running what's called the attestation service, also known as attest-D, right? So attest-D is interacting with the trust infrastructure agent and will store the remote TPM certs in a config store that is actually shared throughout the Trust Authority cluster. Also, on every host in the Trust Authority cluster is another service called KMXD, the Key Provider Service. And this service is working with the KMS server that is providing the keys to encrypt VMs over into our attested cluster. So getting a little closer look, the attestation service, that's the attest-D service, right? This is the service that is running on the hosts that are in the VTA cluster. They will receive the attestation report from the Trusted Infrastructure Agent that's running on the attesting host. That's the one that's the KMXA. It verifies the TPM device is present on the testing host based on verifying the version and the hardware requirements that the TPM was defined when you set this up originally. It also will verify the host version on the attesting host. You can set a limitation of which ESX servers that will be supported for this, and will generate a signed document describing the binary and configuration state of those attesting hosts and defining on whether or not they're trusted. If they are, then we can run those trusted workloads on them. If they're not trusted, then no trusted service can run on that host. The attestation service trust is the configuration that we're defining on the attest-D daemon that sets which versions of ESXi that can be trusted, which TPM device manufacturers to trust, and even which specific TPM devices to trust. The key provider service, the other service that's running on the VTA cluster, is called KMXD. This is the key provider service, which is basically the service that supports the KMS server. That must be a KMIP compliant key server. VMware actually has a list of certified KMS vendors. There's a whole list of them. There's one from EMC, there's one from IBM, there's HiTrust. There's several different certified KMS servers that can be used in this configuration. And the service allows the encryption key access only if a client presents a valid attestation report. So again, if a host does not provide that valid report, then the host will not receive a key from the KMXD service. And if a host does not receive a key, it can't run an encrypted VM in a trusted configuration. And then finally, we have the KMXA, that trusted infrastructure agent that is running on every host that's in the attested cluster, right? The cluster that's being remotely attested to be valid and validated that it can run these trusted workloads. So that trusted infrastructure agent retrieves the encryption keys from the KMXD, right? It'll only receive those keys to encrypt the VMs provided the host, was able to have a successful attestation report. The agent can be issued with encryption keys only if that host passes that attestation, and the host does not receive encryption keys when using a trusted key provider, right? So that means, back on our picture here, there's no way for the host to receive, not that picture, this one, right? Our vCenter server, if there's a KMS on this vCenter server, these hosts will not get keys from that vCenter. These hosts will only get keys through the ESX servers that are part of the Trust Authority cluster. So that was a look at some of the different services that exist on the hosts in this configuration. Nothing that we need to actually turn on or turn off ourselves so much. It's part of setting up this configuration, which then will start the appropriate services, whether you are a host that is part of the VTA cluster, the cluster that's actually going to be doing all the attesting and key management, versus the hosts that are part of the cluster to be attested. Right? Those are your traditional compute clusters, but they're booting in a secure fashion. So take another quick break. We'll come back and start looking at the actual configuration.